Jackson's here.
Good morning, FHS. Today is Monday, January 29th, 2024. Please join me in a minute of silence. Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you and have a great day.
All right, good morning. So today we're going to continue on with our limits unit, and like we've been doing I guess we were only our third day in, but most of our days like this, I'm going to try to give you a little bit more information, a little bit of practice on the new stuff, and then ask you to do a little bit of practice on the stuff we've already talked about so that you build a good foundation there. So the handout you guys picked up, I went ahead and printed this on one piece of paper again. So the front is 69, this is the notes, and then 70 is the back of it. So again, you should number it, so when I ask for one or both of those, you know which one I want to see. So we are going to continue where day one, we talked about what a limit looks like visually. So from a graph and from a table, how can you get a limit answer? We also practiced that a little bit on day two. But our focus on day two was learning about what indeterminate form was, 0 over 0, and how to deal with that with factoring. So we're going to be doing the same thing today, but instead of every single indeterminate form being solved with factoring, it might solve one of two other ways. So I'll show you an example of both those on the front page. Now you may have noticed on the back there that it is not a ton of practice. These questions are a little bit harder, but again, it's really the only hard part about them is the algebra. So questions 1 and 2 are things we already talked about last week. If you were trying to find the limit of a function like this, always start off with direct substitution. If you plug in the number, get a real number, then you are done. If you do not make that a habit, you're going to make some questions long, frustrating, and it's going to lead you to the wrong answer. You have to train yourself to try direct substitution first, no matter what the question looks like. If you plug in and you get any number besides 0 over 0, that makes this fraction undefined, and so we would say the whole limit does not exist. I showed you that last time, and that is still true today. That's still direct substitution, still your first step. You still hope to get a real number because you get to be done. If you have some number other than 0 divided by 0, 5 over 0 is not indeterminate form, so you can be done there as well. But when you try direct substitution on something like this, if you end up with 0 over 0, this is the one that's problematic. Indeterminate form takes more work. So, before I tell you what your 2 new tools are to consider today, you can at least think about what the first and only tool that you have is, and that was factoring. But notice the numerator doesn't factor, the denominator doesn't factor, so unfortunately the factoring is not going to be enough to be able to work this. Okay, this is the same question down here. So the trick to this question is a math process called conjugates, and I'm sure you guys have heard of the word conjugates before, but truthfully, until you get to calculus, you don't really get to see where they're helpful very often. So again, I already plugged in the 4 and got 0 over 0. It's just the same question from above, so I'm carrying it down here. So when it looks like this, and if it doesn't factor, and especially if there's a square root in there, that's how you probably know it's going to be like a conjugate question. So the trick with conjugates is you want to multiply this fraction by 1. Multiplying by 1 doesn't change the size of something, but you're going to multiply it by a very specific one. You're going to multiply it by the conjugate of the part of the fraction that has a square root. So if the square root was in the numerator, you want the conjugate of the numerator. Now conjugate just means you switch the middle sign only. Since this was minus, I want to multiply by plus. Down here, this one is also indeterminate form, so its first step is going to be multiplying by square root of x plus 9 over the square root of x plus 9. Again, anything divided by itself is 1, and multiplying by 1 doesn't change the size. So what we're doing is we're changing the appearance of this without changing the size of it. Okay, so now let's finish question 1 and we can go back and finish question 2. But again, the only reason I know this is conjugates is because it didn't factor, I have to do something, and because there's a square root in there, it gives me a hint that it might be conjugates. Well, to multiply these fractions, you need to multiply your numerators. So FOIL, square root of x times square root of x would be x. Square root of x times 2 would be 2 square root of x. Negative 2 times the square root of x is negative 2 square root of x, and negative 2 times 2 would be negative 4. Now, one nice thing about conjugates, and I don't even bother to write this most of the time, anytime you multiply something by his conjugate, the outer and inner part of FOIL are going to cancel anyway. So if you've learned that, you can skip some of that. We really only care about the first and last part of FOIL. But down here on the bottom, I've got an x minus 4 times a square root of x plus 2. Now you can FOIL those together if you want to, but you would actually prefer for these not to be FOILed together. The way I know that is just like with factoring last class. When you factored, you got something to cancel, and then direct substitution worked. Same thing here. I need something to cancel. Notice my numerator is really x minus 4. So you want the x minus 4 to cancel out the x minus 4. And now that something has canceled, you can try direct substitution for a second time. And as long as you don't end up with 0 over 0, you're finished. Now notice my entire numerator went away, but that doesn't mean it's 0. If your numerator, everything in your numerator cancels out, it still leaves behind a 1. Just like 2 over 4 reduces to 1 over 2. The 2 goes away, but it still leaves a 1. Okay, so again, this one was indeterminate form, just based on how it looks and the fact that factoring doesn't help. That's the only reason I thought conjugates might work. You never know 100% until you try. So we want to multiply these two fractions together. My denominator is going to be a little bit easier because these two are the conjugates. Notice in the first question, I did the conjugate of the numerator, and the second question, I did the conjugate of the denominator. You really want the conjugate of whichever one has the square root in it. So if I FOIL these denominators together, square root of x times square root of x would be x. These are conjugates, so the outer and inner part are going to cancel anyway. Feel free to write those out and then see that they add to 0. And then the last part is minus 81. On the top, when I FOIL these, I would get x times the square root of x, x times 9, negative 3 times the square root of x, and negative 3 times 9, which would be negative 27. Okay, so we kind of have a little bit of an issue here. First off, nothing's canceling. If I plug in direct substitution, we're actually going to get lucky and finish this one. I made this mistake. I worked this out last week. I always like to try to work this stuff out just as a quick little reminder to myself, even though I've done these for years. This one you're going to get lucky. If you do direct substitution, even though nothing's canceled out, you're going to end up with the right answer. I made a mistake on this question, but it's good for you guys to learn from this. Because as much as I try to preach, start with direct substitution and only do all this extra work if you get indeterminate form, it looks like I made that mistake on Friday. If you do direct substitution, you get 3 minus 3 on top, but on the bottom, you get the square root of 3 minus 9. That's not indeterminate form. Only 0 over 0 is indeterminate form. 0 divided by anything is 0. All of that was a waste of time, and it was likely not going to solve nicely, and it was likely to mislead me. Just because it looks like it's a conjugate question, don't just automatically do it. You might be giving yourself more work for a wrong answer. So this is one of 2 new skills I want you guys to practice today. On the back page, there's going to be 5 of the questions on the back page use this type of skill. So you might still need a little bit of factoring, but that's the main one. Okay, the second one I want to show you, and I'm only asking you to practice 2 of these on the back page today, is same idea. Start off with direct substitution. I guess I better actually check this time. The sign of 0 is 0. The sign of 2 times 0 would be 0. This one is indeterminate form, unfortunately. Unfortunately, because that means I have to do a lot more work. And down here, if I plug in pi, at pi tangent would be 0 times anything is 0, so I don't care, over 0. Okay, so that one's indeterminate form too. Just wanted to double check this time. Okay, so now you have 2 skills, 2 tools to solve 0 or deal with 0 over 0. Factoring, which you can glance at both of these and see that neither one factors. Conjugates, but conjugates typically have some kind of square root component to them. So neither one of those 2 skills I've showed you yet will help you with this. The skill that you have to do with this one is you have to make some substitutions with some of the trig identities we'd learned earlier this year. Now, this one is not one that you know, nor is it one that you have to know. I'll just be honest that these questions are kind of hard to come up with. There's not like a website with hundreds of them, like there is lots of math stuff. But this is called a double angle identity. Again, you don't have to know that sine 2x is the same thing as 2 sine x cosine x. Someday when you get to Cal 2, your teacher will expect you to learn that. But the main thing is I'm replacing that with the trig identity. I'm getting something to cancel, just like we did last week with factoring. And as soon as something cancels, now direct substitution should work. Nothing left here, so 1, 2 times the cosine at 0, and the cosine at 0 is 1. So for trig questions, just be careful with the unit circle. If you accidentally say this is 1 instead of 0, or this is 0 instead of 1, then of course that's going to throw everything off. Okay, same thing with this one. Factoring doesn't look good, conjugates don't look good, but there is trig function, so I can probably make some kind of trig substitutions. If you remember last semester, probably the thing that we did, or at least what I think was the hardest that we did last semester, were trig proofs, where you had something like this on one side, something else on the right side, and you had to make the left side look like the right side. Honestly, you don't have to do trig proofs in calculus, but you do have to think of ways, you have to be creative on how to make this look differently. So the real reason we did that and put you through that last semester is to make this a tiny bit easier. So what I would probably try is maybe change tangent into sine over cosine. Then I can see that the cosines are going to cancel, and then the sines are going to cancel, leaving me 1. So you can now do direct substitution. It's just that there's no x's to plug into this, so you can't plug pi in anywhere, so your answer is just 1. So again, not a hard trig identity. I know you know tangent is sine over cosine, but you have to sometimes think to try that to make it look differently. Again, I will try to find some more practice of those at some point, but also don't forget that you can always check these by graphing. So if you graph this in your calculator, in radian mode of course, and you look a little bit to the left of pi in the x direction and a little bit of right of pi to the x direction, you should see that the y value gets close to 1. So last time I asked you to do that a couple of times to practice. Today there's only 7 questions on the back, so it might be worthwhile to just do them all that way. But I will graph this one just to make sure you see what, remind you of what I'm talking about here. Okay, so here is the last question we did. Tangent times cosine over sine. My calculator understands that that all reduces to just 1. So it doesn't really matter what x value you approach. Just like when I tried to plug in pi for x, there was nowhere to plug in x. So you can do trace pi enter to jump to that spot. Notice there's not even a point there. At pi, the point does not exist, but limits are different than points. Move your cursor a little bit to the left. You can see that it approaches 1 from the left. Move it a little bit to the right. See that it approaches 1 from the right. And if it approaches 1 from the left and 1 from the right, you can feel good that that was your correct answer. Again, you'd have to make sure your calculator's in radian mode, though, if you're doing trig functions. You guys know we do a lot of stuff in degrees and radians. Calculus is 100% radians. We don't do anything in degrees. Okay, I would like you to flip the page over, and before you try any others, I would like you to try question 1 and question 6. We'll do, even though you don't have a ton of practice on this page, 1 and 6, I'd like to give you a chance for some guided practice. So once everyone's had time to try those 2, I'll go over them to help you maybe catch some mistakes that you may be having. again, part of why I put less questions on this one is that some of these questions take a little bit longer and you need a little bit more space. Some of these will take 3 or 4 steps per question, so. Of course, I'm going to be pretty patient here, so especially since this is the very first question. So if you're 100% stuck or think that you have it completed, both of them, of course, go ahead, just keep on going. You can rejoin us once I think everyone's had time to get to that point. And again, just because we did factoring last time doesn't mean that there will be 0 factoring in this. You may need to do a little bit of factoring to get something to cancel. Just shouldn't be your first step. Okay, I'm going to assume that you're either close to finished or you at least realize where you got stuck. So question 1, I ended up with an answer of 1. So if you think you did it correctly, but you did not end up with 1, then you need to follow along with this here. So you try to plug in 3, always direct substitution first, but this gave 0 over 0, which means you have to do more work. This doesn't factor, this doesn't factor, there's no trig identities, there's no trig identities. The only other tool I've given you at this point is conjugates. So the conjugate of the square root of 2x minus 5 minus 1 would be the square root of 2x minus 5 plus 1. You only change the sign in between the two terms. And again, anything divided by itself is 1, so I'm really just multiplying by a really fancy 1. Multiplying these two, you could FOIL. The square root of 2x minus 5 times the square root of 2x minus 5 is just going to be 2x minus 5. Because these are conjugates, the outer and inner are going to cancel out anyway, so I didn't even bother to show that. And then the last part of FOIL gave me negative 1. On the bottom, I have an x minus 3 times all of this stuff, so I just left it like that. And the reason why I knew not to try to multiply that together is because I could kind of see that the numerator was close to an x minus 3. You could combine minus 5 minus 1 to a minus 6, and then 2x minus 6 has a GCF of 2, so you can factor out a 2, and then finally I got the x minus 3's to cancel. Plugged 3 into what's left over, I got 2 over the square root of 2 times 3 minus 5 plus 1. So I ended up with 1 in the end. And I'll put this back up in just a second so you can make corrections if you need to and see if you need to ask questions. But I did graph this in red, or I'm sorry, blue. So if I do trace 3 enter, it jumps to that part of the graph. It tells me there's not a point there, which is fine, has nothing to do with the limit. But if I move the cursor a little bit to the left, I can see that it looks like it's approaching 1 from the left. Move the cursor a little bit to the right of 3, you can see that it looks like the y value is approaching 1 from the right, and if it's approaching 1 from the left and 1 from the right, that all but guarantees that we did that correctly. Now again, use your calculator to graph and check your answers, but of course don't be doing that to get your answers. Part or all of your tests may be no calculator. So. Okay, so make the corrections you need to make, and is there anything you'd like me to answer or clarify for you? Okay, then the other one I wanted you to try was number 6, one of the 2 trig questions. Of course, I'll help you guys with the others if you need it, but I'd like you to try all the rest later. So, same idea, same starting process. I guess I can tell you the answer since I've worked it out. It's supposed to be 1/4. If you did not get a 4th, no matter if you think you did it correctly or not, you need to follow along here. So, same first step, try to plug it in. Unfortunately, we get 0 over 0. You're going to have to think about unit circle to be careful with that. So, nothing factors yet. There's no conjugates because there's no square roots. And then the only other one I've given you is trig identities. So, I mean, I guess you could make cosine be 1 over secant. That's not real helpful. Eventually, ultimately, and this is still on your desk too, by your desk number, the first Pythagorean theorem, sine squared plus cosine squared equals 1, you could rearrange that. Sine squared is the same thing as 1 minus cosine squared. And that's the only real substitution I knew to make. So I didn't know that that was going to work the first time I did it, but I also didn't see what else to really try. You have to try something. And then it's tempting to try to make these cancel out, but this one's squared and this one's not. So then I factored. 1 minus cosine squared is the difference of 2 squares. You've got 1 being squared on the left, cosine being squared on the right, and difference of 2 squares always factors as 1 minus and 1 plus. And I thought to do that because I knew something had to cancel. I knew I should try to make that look different to where it had a 1 minus cosine x. That was the only hint that I had. So now everything had been canceled out of the numerator, 1. The denominator was 2 times this stuff. And when you finished with direct substitution, this was 1 plus 1, which was 2. And in the end, you get 1/4. Once again, I'll put that back up in just a second. But this one was as x approaches 0. I put it on the same graph. Okay, so trace 0, enter, jumps to that point. Point doesn't exist, doesn't matter. Cursor a little bit to the left. Oh, I'm on the wrong function now. Okay, a little bit to the left of 0. Looks like the y value is getting close to 0.25. A little bit to the right of 0. Looks like the y value is getting close to 0.25. And 0.25 is the same thing as 1/4. So that all but confirms my work there. Now again, I know those are not easy. You can't always see, oh, do this step, and then instantly I'm ready to do this step, and then instantly I see to do this step. A lot of times you're going to have to look at it and say, I don't know what to do, but I could maybe make this look different, and then you run with that for a couple minutes. Maybe it helps, maybe it doesn't, but that's the approach you got to take. Okay, is there any specific about number 6 you'd like to ask? Okay. All right, so the rest of class, I would like you to first finish this up. So you've got another 4 questions that do conjugates, like number 1, and 1 more that do trig identities, like number 7. And I will ask you guys for questions at some point if you need me to help you with 1 or 2 of those on the board, but you need to try all those on your own first. So that'll finish up number 70. Then I would highly suggest you look back at your very first handout we did from day 1, where we talked about what a limit looks like from a graph and from a table. There's 2 things we talked about on there that I have not had you practice yet. One of them is estimating limits from a table. We did like 2 problems on that worksheet, but I haven't had you really practice it. And one-sided limits. So if it's just a limit from the left or just a limit from the right, but not necessarily both, I have not had you practice that yet either. So once you finish number 70, look over your notes from the first day for just a minute or 2 where we talked about this. And then these 2 are both in Khan Academy. And then that assignment from last class, number 67, I hadn't asked you to turn that in officially yet. Some of you already did because you saw it in Google Classroom, but if you haven't turned that in, you need to turn that in before you go. So that's the plan for today. So go ahead and start working on finishing up number 70, please. Now my website should have the answers to all of those, but again, I do recommend that you try to check a few with your calculator also. The more times you practice that, the better you're going to understand visually what a limit is. Even though you did it on day 1, it takes a lot of practice before it really sticks. So. Okay, and I will ask for questions on the board in about 15 minutes. So if you get hard stuck on one, just move on to another one. Also, just a reminder, there's a few of you that need to make up your quiz tomorrow. I know you've not been able to because of CAP during advisory, but there is movement this week after today, so. So I already have you scheduled for tomorrow, just giving you a reminder, but you might want to look over your notes to that if you haven't already. Okay, about 4 more minutes and I'll take a few questions on the board. So now that you've had time to try some more of those, is there one or two of these I can help with? Any of them that seem harder than the rest?
Did you use number 2?
2? Sure. Alright, so step 1. Again, I know it's tempting to just jump into what you think you should do, but make sure you need to first. Plugging in -1 gives me 0 over 0, so unfortunately I do have to deal with this indeterminate form. No factoring to be done, no trig equations. The only other one we've talked about is conjugates. Bless you. Bless you. So the part with the square root is in the denominator, so I really want the conjugate of the denominator. So the conjugate will be the square root of x plus 5 plus 2. You only change this one middle sign. You don't change multiple signs to get conjugates. And whatever you multiply the bottom by, you need to multiply the top by. That way it's like you're multiplying by 1, changing the appearance, but without changing the size. So we got to see where the dust settles here. I'm going to do the denominators first. Multiply these fractions together. You got to multiply the numerators and denominators. But the denominators are conjugates, so that's a little bit easier. Square root of x plus 5 times square root of x plus 5 is just going to be x plus 5. You can do the outer part of FOIL and then the inner part of FOIL if you want to, but those always cancel and go out to 0, so you're also welcome to skip that. And then the last part of FOIL would give you -4. And I'm just going to go ahead and change that real quick to an x plus 1. Plus 5 minus 4 is plus 1. Now when I look at the numerator, I guess I could FOIL these together, but I'm going to want an x minus 1 to cancel out anyway. So I'm just going to leave it x plus 1 times this stuff. I'm not going to actually FOIL it, because I want this stuff to cancel anyway. Now that something is canceled, direct substitution should work. Plug that in, we get the square root of 4 plus 2, which would be 2 plus 2, which should be 4. Is that enough?
Yes, thank
Okay. Anybody else is going to ask about number 2? And part of what's tough about this one is knowing not to FOIL those numerators, and I don't have an easy answer for you on that. I always FOIL the conjugate parts first, because it's a little bit easier, and then sometimes it helps you see that you didn't really want to FOIL those numerators. You can try that, but you can see it, you kind of hit a wall if you do that. You need something to cancel, just like we did with the factoring last week. Until something cancels, direct substitution is not going to work. Okay, anybody else want to ask anything else about number 2? Okay, I'll take one more question for now, and then go ahead.
Did you do 7?
Number 7? And then I'll set another timer and give you a chance again at the end. Okay, so same first couple steps, direct substitution. Hope we don't get 0 over 0, but if we do, we got to make it look different. So pi over 2, this would be 0, square root of 0 times 3 is 0. Sine at pi over 2 would be 1. 2 minus 2 times 1 would be 0. So unfortunately, this is indeterminate form. Again, if you don't check that, you are going to get the wrong answer sometimes after doing a lot of work. Now, I've only got 3 tools at this point. Again, we slowly add on to this. This is why you guys need to try to feel as comfortable as possible as we move through, because you will get overwhelmed eventually if you don't. But factoring, well, not really, but I guess in the denominator here, you could factor out a GCF, so I don't know if that's helpful or not, but I could do that. Nothing seems to factor in the numerator. Also, I don't feel like I should get conjugates out because there's no square roots. Nothing else factors. No square roots, so no conjugates. So the only other option is trig identities. So right here, similar to the other one, those of you going on to calculus next year, this is one of the trig identities they expect you to know in calculus. Sine squared plus cosine squared is 1. So instead of saying cosine squared, I could say 1 minus sine squared. And because these questions are a little bit longer, you're going to be doing yourself a disservice if you make your handwriting too sloppy or you try to squeeze your work in too small of a space. You're going to make it harder than it needs to be. But it's very tempting to make these cancel, but these are not the exact same thing. This one's squared, this one's not. Luckily, like the other one we did, we can factor this. It's the difference of two squares. One's being squared on the left, sine's being squared on the right. Difference of two squares is always a plus and a minus. And my hint to even consider doing that is because looking at the denominator, I realized if I did that, I could see that these two things cancel out. Okay, and then now to get the answer is going to come from 3 times 1 plus the sine of pi over 2 over 2, because everything else canceled. So looks like the answer to that should just be 3. So we needed a little bit of factoring at the start maybe, and at the end. GCF at the start, difference of two squares at the end, and we needed one trig identity to move forward. Knowing cosine squared is the same as 1 minus sine squared. Okay, does anybody have anything specific about 7 while it's still up there? Okay, go ahead and keep on going then, and I will ask for more questions on the board in another 15 minutes. Remember though, as you finish that up, because I know some of you are probably close if you didn't struggle much, I'd spend a couple minutes looking at your first worksheet, number 65, to remember how to do limits, one-sided limits, and limits from a table, and then you need to do those 2 Khan Academy assignments. So you felt free to move on to that as soon as you're done with the worksheet. Oh, sorry. Actually, I have to assign these. The Khan Academies won't show up just yet. I need a second to assign them to you. I thought I already did this. should show up in Khan Academy now, if that's where you're at. Once again, it's probably a good time to point out to you, probably will say this every day of this unit, but this is a very good example of what is challenging about calculus. The idea of limit's not that hard. Knowing to do direct substitution at the beginning and end is not difficult. Knowing that you need to make that look different is not that tough. But the algebra of conjugates, the algebra of foiling, the algebra of reducing your fractions, the trig identities that you have to know, the factoring you have to know, all of that stuff that you have seen in the past. You know, each calculus question can make you try to apply 2 or 3 or 4 even of those old things. So it's not usually the calculus that students find to be difficult. It's all the algebra and trig that comes along with it. more minutes and I'll offer another question or two on the board. Okay, one more chance for today. Any questions? We already did both the trade questions, but any of the other, there's only 3 more. Any of those that I could help with? Yeah. Number 5, sure. Okay, so always, step 1, direct substitution, but you get 0 over 0, so we've got to do more work. Just based on how this looks, I make a reasonable guess that I should probably multiply by the conjugate. So, not the conjugate of x minus 2 because there's no square root there, but the conjugate of this one. So you should have tried to multiply the top and the bottom by 1 plus the square root of 3x minus 5. It's got to be top and bottom so that you're not changing the size. And again, you only change this one middle sign to get a conjugate. You don't also change the sign. I mean, you can do that, it's just then the conjugate's not helpful. So now I will go ahead and multiply my denominators. So 2 terms times 2 terms, you probably learned that as FOIL. First part of FOIL, 1 times 1. The outer part of FOIL would be the square root of 3x minus 5, but then the inner part of FOIL would be minus the square root of 3x minus 5, so those are going to cancel out anyway. And then this is one place where I would be a little concerned. There's an easy algebra step to mix up here. The square root of 3x minus 5 times the square root of 3x minus 5 is going to be 3x minus 5. But one is positive and one is negative. So that means that this is negative. A positive times a negative is negative. You guys tend to, well, maybe not you, but calculus students tend to say, okay, this thing is negative. But if you do it that way, you're saying that only the 3x is negative. And it's not the 3x that's negative, it's the whole thing that's negative. Positive times a negative is negative. The whole thing is negative. So in the top, I've got an x minus 2 times this mess. I'm going to try to avoid doing anything with that if possible. And I'm going to hope that I can make this denominator look like an x minus 2 so I can cancel those out. So if I distribute, I get a negative 3x plus 5 plus this one gives me plus 6. And I could factor a GCF out of that. And now I can finally see that the x minus 2's cancel. Again, if your work is too hard to read, then you might miss it at the end for carelessness, but plug 2 into what's left over, which would be this. Over this. And the denominator only had a negative 3 left over. The rest got canceled out. So I would go with negative 2/3. But again, I would say for 90% of the people that missed that thought they got it right, it's this right here. Positive times a negative is negative. But it doesn't mean the first term's negative. The whole thing is negative. You got to make the 3x be negative and the minus 5 be negative. Or just put in parentheses so you don't forget that. Okay, anything more specific? Okay, if you're still working on that, that is fine. I don't have any issues with that, but even if you just followed along with me, you've only got 2 more, even if you did not work ahead, so make sure you finish that up. That'll be one I certainly asked for at some point. The 2 Khan Academy assignments, and make sure you turn in your work from last class. I'll put the agenda back up so that you can read all of that. And if you've not started the Khan Academy, I'll tell you there's already 10 people who've already finished it, so it does not take a long time. So if that ends up being homework for you, it shouldn't be a big deal, but I am doing my best to make you try to think about the past stuff that we've done so that it doesn't escape your brain between now and your quiz. Your next quiz will still be a couple weeks away from now. Okay, so if you guys do have any other questions you'd like me to help with while you're here, just let me know.